I'm happy to welcome all of you, and in particular, our speaker for today, Robert Bracey. Robert, I'm sure, is known to many of you. He's a former editor of the Society's Journal. His primary research interest is in Kushan history and numismatics, and he's been engaged with Joe Cribb for the last several years in writing what I expect will be the definitive catalog of Kushan coins. Robert also generates a lot of online historical and numismatic content, and was recently appointed curator of Asian numismatics at the British Museum. He'll be speaking today on a very interesting topic that he calls numbers as sources. So Robert, I'll let you take over at this point.
Okay, thank you very much for that. So essentially, I'm going to be talking today about the way in which we interpret numbers in numismatics, because that's an increasingly large part of numismatic research, is interpreting numerical data of one sort or another. So one area where it's very obvious is in die studies. I didn't want to do this talk about die studies because we don't have a lot of them in South Asian numismatics. And if you want to understand the way die studies are use numerical data, it's probably best to go and look at die studies that have been done in the Greek, Roman Republican, or English medieval coin series. So most of what I was planning to talk about today is about metallurgy, about gold content in Kushan and Gupta coins. And I was actually going to begin, and for this I'll need the slides, with a discussion about a recent set of articles in which Nikolaus Schindel and Joe Cribb have argued over the interpretation of an overstrike to introduce some basic concepts. One of the things I'm going to talk about today, as I talk about numbers, is the analogy of a bag of sweets. Whenever we're thinking statistically about numismatic data, one of the things that's going on, or a good way to think about it, is you have a bag of sweets, you reach into the bag and you pull a sweet out at random and you eat it, and it's a toffee sweet. And then the question arises, okay, well, the sweet I ate was a toffee. What does that tell me about the rest of the sweets that are in the bag? And that's whenever we're dealing with numerical data in a historical situation, is almost always what we're doing. We have a surviving sample of material and we're trying to extrapolate from that to what originally existed. And I always find it useful whenever you're struggling with a bit of it or trying to make sense of it, to come back to that very simple analogy. You've got a bag of sweets and you're reaching it into it and you pull something out. So I'm going to come back to that over the course of the talk. I want to talk about, within that analogy, two extreme cases that I think people get their heads into when trying to apply numbers to historical situations. And that's essentially people try to say either I can say lots of things when I've pulled one toffo out of the bag, or they say I can only say something once I've taken all of the toffos out of the bag. So you get people who say the moment you've got one sweet, you can say something useful about the bag. And you get people who say you can't say anything useful until you've seen all the sweets that are in the bag. I think both of these are fallacies. And one of them derives the idea, the one toffo example derives from the idea that any data is better than no data. And you can always do some sort of interpretation on it. And I think it's a misunderstanding of historical methodology. In history, routinely, even though we don't really think about it very much, we discount large amounts of data all the time. It's when we talk about primary sources, what we're doing is excluding huge chunks of data and essentially saying those are not usable for interpretation. And all the Tophos fallacy, I think, derives from a very common assumption people make that in historical studies, we never know anything for certain, right? Which again, I think is a misunderstanding. While if you're a philosopher, it's absolutely true, historians never know anything for certain. But if you're a philosopher, that's true for every academic discipline. So it's not a special case for history. I wanted to begin with an example that illustrated that one TOFO problem. And these are two articles that recently appeared in the journal. And I'm assuming most people get the journal who are on this presentation. So you can always go back and take a look at them. Joe Cribb and a group of people published an article about a Perros. This is a 3rd century coin. Everybody's agreed it's a 3rd century copper type made by the Kushan Shahs in the northwest. And Nicholas Schindel produced a rebuttal to this article. And as you can see, these are very grotty copper coins. The argument that was made in the first article is that they are both overstrikes. Depending on how good the image on your screen is, you may be able to see red lines drawn on top of the images, which indicate where Joe Cribb and team believe the undertype is, which they believe is an issue of Shapur I made at Merv. And this is the conclusion they drew from that the existence, I'm going to quote it, the existence of two overstruck examples of Shapur I by issues of Perros I Kushan Shah suggests the ready availability of examples of the overstruck type in Kushan Shah territory. The most plausible explanation, they then conclude, is the two are roughly contemporary. So you can use the known dates of the issues of the Merv to date Perros I. For anybody who's unaware of this, there is a long-standing and very fractious argument over the dating of the Kushan Shahs, in which Joe Cribb and Nicholas Schindel are on different sides. Now, in this very specific case, it's worth saying, I agree with Joe Cribb on the dating, but here I'm going to agree with Nicholas on the methodology. The issue at stake is essentially, what can you tell when you have one overstruck coin? Nicholas's argument is all you can tell is that that type must have finished later than the type it is overstriking, must have begun later than the type it's finished. So, sorry, it's a terminus post quem. One of them has to come, the overtype has to come after the undertype. But you can't tell any more than that. You certainly can't argue that they're contemporaneous, which is the argument that Joe Cribb makes. Now, I think that Nicholas Schindel is essentially correct in this point, but I think it would be wrong to extrapolate that this point is always true. Nāpāna's coinage is famously overstruck by the Satvahanas in enormous quantities. There are thousands of examples of these overstrikes, which you can see on the screen here. The overstrike that's going on is essentially, this is the bust portrait, and that three-arched hill has been stamped on top of it. In that case, you could not make enormous quantities of overstrikes if it wasn't the case that you had access to enormous quantities of the undertype. You have to have large numbers of coins available. And in most cases, the most plausible explanation for why you have large numbers of coins available is that you are dealing with near contemporary coinages, not coinages that may have occurred 50 or 100 years later. So in cases where we have lots of data, we can often draw an interpretation that is different to cases where we have a single data point. And I think of this as a continuum that is a normal part of historical methodology. We have situations where something is for all practical purposes impossible. We have situations where our interpretation is nearly certain. Most of the time, we're arguing over interpretations that fall in a middle ground, which we can think of as running from possible through plausible to probable. And the argument that is taking place between Nicholas and Joe is essentially about where one or potentially two overstrikes falls in that continuum. I think a central idea, which is very important in handling any set of numerical data in numismatics, is what I'm going to call the threshold of inference. This is essentially a point where the data just isn't compelling enough for you to draw conclusions. It's not that you should say something is false rather than true. It's literally that you should just not draw any inference for it. And I think in this case, this is a good example where Nicholas Schindel is right. A single overstrike of this type could just be that the coin remained in circulation for 50 or 60 years and then got overstruck. If we had 20 of these or 30 of these, that would be an entirely different matter. But one or two of them doesn't really tell us anything. And part of the reason for that is that as historians, we go out of our way to systematically search out unusual examples like the overstrike. So we need to be very careful of then making a statistical inference from something that we have actively sought out in the first place. Now, the rest of my examples are going to be about metallurgy and Kushan and Gupta gold coins. I'm going to explain some things just in case anybody doesn't know. Apologies to those people who are already familiar. I'm going to be talking here primarily about two measures of a sample. The mean, which is one of the three types of average you commonly take from samples. So it's essentially, if you did this at school, you add up all the values and you divide it by the number of examples, and that is the mean value. It's a measure of the center point in a sample. And the standard deviation. The standard deviation is a mathematical measure of how much individual data points deviate from the mean. So why am I talking about standard deviation rather than simply talking about the range of values? The answer to that is quite simple. The range of values in a sample is enormously dependent on the size of the sample. If you have 4 or 5 coins you have measured, your range will be smaller than if you have 20 or 30 coins drawn from the same type that you measure. Because you get outliers at the edges, the more coins you get, the more outliers you're likely to have. That applies to some degree to standard deviation, but it's much less of a problem than it is with range. Standard deviations tend to be much more comparable between samples of different sizes. And we did get a comment there. Yes, the comment was about the different types of averages. Yes, the mean is the arithmetic value you calculate by taking all the types. You've also got two others. The median would be straight in the middle, within the sample itself. And you have the mode, which is the largest group within that. So yeah, I'm not worried too much about how we calculate them here. I'm just trying to make sure everybody's up to speed on what we're going to be talking about in the next section. And this is some data from one of Pancarger's articles. Right? This is gold percentages calculated by XRF examination of Kushan coins of the 2nd century from Vima Kadphises to Hubishka. And these are presented here as a scatter plot. So the scatter plot simply has two sets of data and it presents the each individual data point according to its value on the two sets of data that you've got going on. And in this case, I hope Pankaj doesn't mind me speaking for him about how the chart works.
Go ahead. I might have to correct you, but go ahead.
Yeah. So on the left-hand side, on the vertical axis, you have the percentage of gold as measured by the XRF machine. At the bottom, the coins have essentially just been placed in an order to give you a second axis so you can see everything. And that's why date in the title is enclosed in quotation marks. These aren't actual dates of issue of coins. The coins are just arranged chronologically, roughly from left to right. I think that's a fair description of it.
Yes, they're meant to be sort of by date. We don't know the dates, but the dates on the x-axis are indeed the Common Era dates. So Kanishka
Of the
starting in
kings,
127.
but
And
not
then,
of the coins.
right. And then the coins themselves were arranged in order of your catalog, Robert,
Yes.
so that they're roughly going from earlier to later.
Yeah. And now, I think scatter plots are an excellent way to present things, but I'm going to be presenting data to you slightly differently because I think sometimes when you look at data as individual data points, it can become very overwhelming and it can be very hard to discern patterns in it. So I want you to take away that the general pattern of this is an apparent gradual downward slide in the gold content of the Kushan coins. I'm going to be using something called a dynamite plot, and I'm just going to briefly warn you that while dynamite plots are extremely popular with people like myself who work in fields that use numbers, they are universally hated by statisticians. So let's skip forward one and I'll explain how a dynamite plot works. So this is the same data that Pankaj published, now as a dynamite plot. You can think of each of those graphical representations which vaguely resemble a cartoon dynamite plunger, which is where the plot gets its name from, as being like a single bag we've taken sweets out of. In this case, these are the fourth phase coins from the main mint of Huvishka, which are sometimes known as the young prince type because of the apparent youthfulness of the king's portrait. And this is composite data about all of the coins of that type that were measured. The central line is the mean value. The grey boxes either side of the mean are one standard deviation, so indicating the distribution, how widely distributed coins, individual data points are around the mean. The black arrows indicate the range, so the total range of values. This is why we don't use the range, because you can see that if we jump back to the first phase at the second mint, the range is actually smaller than the standard deviation. That is a normal oddity that happens when your sample size is very small. It's due to a correction that's done mathematically in the formulas for standard deviation. So when your sample size is small, your standard deviation ends up being larger than the range of values. So again, it's why, generally speaking, the standard deviation is comparable between different groups of coins. It indicates if one group of coins is more spread out in its values than another. The range is generally not. It's useful because it can be incorporated in the chart to indicate the range, but it's not the main piece of information we're trying to make sense of. And exactly as with the scatter plot, the reason to represent this graphically is that the data tables themselves are very hard to interpret. If you simply got a wall of numbers, this is all of the data that we have from 30 years of the British Museum undertaking specific gravity tests on Kushano-Sasanian gold coins from the 2nd to the 4th century CE. And this is all of the aggregate we can do that with that. So essentially, for every phase of production we have identified numismatically, if at least 3 coins are available to us from which we can draw data, we have calculated a mean and a standard deviation for that phase. Again, because of the difficulties of interpreting 1 or 2 things, I'm excluding every phase of production where we only have 1 or 2 test results. Again, that concept of a threshold of inference, I'm simply putting that data to one side. There's just not enough of it to be useful. For those who are interested, this is the sort of graphical representation of the gold production in the 1st to 4th century in the Northwest. So Afghanistan, Pakistan, Northwest India. And the diagram on the left shows all of the gold production together. The diagram on the right grays out all of the places where we don't have at least 3 data points. And you can see immediately there's some very substantial gaps in our data. We have 500 to 600 specific gravity results. And as you can see, we're probably still at least half of the production phases that we identify numismatically. We don't have enough data to make a reasonable interpretation of. This is one of the things that's fundamentally altered in the last sort of 20, 30 years. We've portable XRF machines nowadays, but specific gravity in the last 20 or 30 years have made it possible to test enormous numbers of coins, and therefore have made it more important that we as numismatists get used to handling numerical data that derives from those kinds of tests. Can we skip one slide forward?
Before we do you mind if I ask a question of clarification?
No,
I haven't quite understood what's on this graph.
Right. So this is literally just a visual representation of the minting running chronologically from top to bottom, with each little block representing a phase and denomination.
Okay, so it's just a summarization of the data you have. It doesn't actually tell us anything about what the specific gravities were.
No, the chart on the right grays out everything you don't have specific gravity data for. Yeah.
I got that.
This just indicates what potentially we would like to have specific gravity data for. I'm aware of the kind of nature of this talk, and I would much rather that people turned off their microphone and interrupted to ask a question than didn't understand what I was saying. So this is data from specific gravities covering the period from Bhima Kadphises to Vasudeva I. So this is slightly longer than the scatter plot that we showed from Pankaj's article earlier, but it's covering a very similar range of material. And I've kind of illustrated roughly what the coins we are looking at look like. Again, the plots work the same way. The mean is the middle line. The grey boxes are a standard deviation each side of the mean. I've marked in phases that we don't have data for in light grey, so you can see we have quite a lot of missing data, especially for the early part of Huvishka's reign. And I wanted to make this point that the higher the level you look at, the more likely aggregating data is to conceal something interesting. So on Pankaj's scatter plot, it appeared that we had a just gradual decline in gold standard. And that is how most of the early tests of Kushan coins were interpreted. It is to a degree how these tests were interpreted because they were allocated by reign. So people said this is the average for Vima, the average for Kanishka, Huvishka. Once we break the data down to individual phases of production, you can see that it's actually significantly more complicated than that, right? The slightly darker gray boxes for the standard deviation are used where it's the subsidiary mint, which I believe is located near Taxila, rather than the main mint, which is located near Balkh in Afghanistan. Under Vima Kadphises, there's only one mint. Towards the end of the reign of Kanishka, a second mint is opened in the south. That mint, in most of its procedures, appears to follow the lead of the main mint. But one of the things you will notice is occasionally it strikes coins apparently to a higher standard than the main mint does. They don't perfectly align in terms of the gold content of the coins. You'll also notice that there are periods when the phase is nowhere near as tight. There's much more variation in the gold content. This happens in the second phase of the main mint of Vishka, in the third phase of the subsidiary mint, at the beginning of the reign of Vasudeva, at the very end of the reign of Vasudeva. And again, that's a feature that's easily lost when you move up to the aggregate level. And I think that there are a variety of reasons that that's occurring here. I think in some cases, it's a loss of control by the mint. In some cases, it's that the phase is actually marking the point at which the mint reduces the standard. So the group of coins contain both low coins that were struck to different standards, which obviously, when you aggregate them together, makes it look like there's much greater variation within it. So what this suggests is, first of all, that there were attempts to reassert gold standards by the Kushans, and also that they tended to be reduced in steps. So it wasn't the gradual decline the scatter plot indicated for us. It was mostly that a relatively constant standard was maintained, and then there were moments of decision where the mint deliberately reduced and went to a new standard, and that standard was then maintained. So breaking it down in this way makes it, I think, it makes features of the mint's operation more apparent, right, than when we operate either with individual data points, which are hard to interpret, or with very high-level aggregate data, which tend to hide these sorts of patterns. I've picked these four out. These are from the specific gravity tests. You can tell that because they say 18 and 19 on the scale at the side. Specific gravity is a measure of density, and it's measured as a ratio to the density of water. Gold is approximately 19 times denser than water. These are the four phases in which we have three or more points of data from specific gravity, and Pankaj, in studying the Swabi Horde, had three or more points of data from XRF tests. So it gives us a moment at which we can compare. I want to draw your attention to a specific thing, which is that phase 3 of the secondary mint, that's on the right, is much tighter, but has a very similar average to phase 2 of the main mint. This is the same data from the Swabi Horde. And you should notice there's a fundamentally different relationship between the two sets of data, right? Here, phase 3 at the subsidiary mint has a much lower mean, and it appears to have a more diverse range of values. I want to say, first of all, it's possible that I messed up in transferring the data when I was producing the charts. It's possible that there's typos either in my data or less likely, I suspect, in Pancage's. But what I want to say is it's not necessary for there to be a mistake for one or both of those data points to be wrong, because at least one of them has to not accurately represent the original coinage. Right? They can both be accurate measures of the samples they're measuring, but they can't both accurately reflect the gold content of the original coinage because they're different. And to talk about why that might happen, I'm going to actually move on to some Gupta examples. I'm going to talk about 3 other related statistical concepts, and those are statistical significance, confidence intervals, and the null hypothesis. Here, I'm going to be using data from Pancage's article in Ellen Raven's Festschrift, and the reason I'm picking on Pankaj here, some of this data actually comes from Sanjeev Kumar, is that Pankaj was doing XRF testing on both, and obviously he's the same person and is operating under a very similar methodology, so they are relatively comparable, the data he's drawing from the Kushan material and the data he's drawing from Gupta material. Skip on 1 from this. So this is a table from Pankaj's article, and I'm going to start. What's the null hypothesis? In statistics, the null hypothesis is the hypothesis that the differences, that the data looks the way it does through random chance. So it's purely a function that you pulled out things. So if we go back to the bag of sweets analogy, Pankaj and I are drawing from the same bag of sweets, which is Kushan coins of the reign of Huvishka. But when I reached in, right, there's a mixture of sweets in there. I only pulled out lemon drops, and when Pankaj reached in there, he only pulled out sherbets, right? So there was a mixture of both in the bag, but simply by random chance, we just pulled out, right, different things. That's the null hypothesis, and that's generally, when we talk about statistical tests, that's what they are measuring. And they measure this by what are called p-values, which is essentially what is the chance that the difference you see arose because of a random selection. The assumption that underpins it when you calculate a p-value is essentially you're drawing from the same sample, but what's the chance your data looks different in the way that it does, simply, right, randomly, right? How likely are you to have drawn different data from the same sample? The first thing to say is it's incredibly difficult. People struggle, everybody struggles with truly random data. If you draw random samples from the same thing, 2 different people do that, their samples will look different. They always, any time you do something randomly, you don't get the same result. You get different results. So it's always a question of trying to understand, okay, well, these things are different. Are they different enough or different in a way that makes us think that it's not simply the random selection that's causing that? Now, in history, we have an additional problem on top of that we almost never have actual random samples. Our samples have been selected in some way that involves a degree of conscious decision making. But, right, let's tackle this problem to begin with. This is data for Samudra, divided up by the coin type. Presented in the same way again, which is the dynamite plot showing the mean in the middle of the 2 grey boxes, which are 1 standard deviation either side of the mean. I want you to know how tight the Tiger Slayer and Archer are compared to all of the others. This again comes from Sanjeev and Pankaj's XRF tests on Gupta coins. If you look at Pankaj's article, you'll see that the scepter type has a slightly lower mean value in Pankaj's article than it does here. That's because there's a single coin, which I think was measured by Sanjeev, which had something like a 50% gold, and I decided to simply exclude that coin from the numbers because it was so much of an outlier. I didn't think it was helpful. So that's why if you check these, they'll look slightly different. By the way, I want to say, and it's not just because Pankaj is on the call, right, that if you are interested in the application of statistical tests to numismatic material, the article is absolutely excellent. It's a really good presentation of how you do that and what the issues surrounding it are. And I'm using it because it's got data in it, and I hope Pankaj doesn't mind. I also think it's potentially useful to people, have people hear very similar things explained in the same way. In different ways. So, I am not in this presentation disagreeing with anything Pankaj writes in the article. I'm simply explaining it in my own terms for anybody's benefit. So in the article, Pankaj points out he uses the scepter type as the standard, and he looks to see how much things deviate from that type and whether or not they deviate significantly. In statistics, the word significant has a very specific meaning, and it means specifically that passes a certain threshold for the null hypothesis being unlikely. It doesn't mean that the difference is important, which is one of the most common misconceptions when the term is encountered. The difference could be entirely irrelevant to you, right, and not really matter from a historical point of view. It simply means that the null hypothesis is particularly unlikely, and the standard convention of that is 5%. When I was a student, we used to get drilled into us the difference between 1 and 2 tail tests and whether it was 5% or 10%. And I've noticed increasingly that people just don't really talk about that any longer. And I think that is a function of people accepting that the statistical significance threshold is a largely arbitrary line, which is useful, but not something to get terribly hung up on. But for the moment, the important point to think about is that when you do a statistical significance test, the test is saying you're only going to get a result this wildly off about 1 in 20 times. I just want to note those two samples are very small, right? There's only 3 and 4 coins respectively in them. That, to me, makes me worry about the validity of the data with those two. In a way, I worry less about the king and queen type. So always be aware of your sample size. That's right on the borderline where I would have excluded them completely. Next slide. Right, so this is, I've already said, statistical significance is, essentially this threshold. You'll often see p less than, and whatever the p-value is written after it in articles, and that's all they're saying in the article. The null hypothesis is this probability. Pankaj in the article makes 29 comparisons of types for which there are p-values, and 4 of them have, for both the actual gold and the percentage of gold, a p-value that is less than 0.05, i.e. that makes the statistical threshold. And therefore it's potentially interesting to us. But I want to flag up a problem we often have as historians, because we don't work the same way that the people who initially used these statistical tests work. We tend to gather lots of data and look for outliers and oddities to interpret. If there are 29 tests, even if all of them were drawing from the same thing, we would still expect one of them, because it's a 1 in 20 chance, to have a p-value less than 0.05. There would be an outlier simply by random chance, right? So we always have this problem when we look at this. We're asking not just, oh, okay, those 4 appear to be off, but we're also asking, well, okay, but is one of those 4 off simply because of the sample being odd, being an unusual random sample, right, that just happens to contain coins that have particularly high or particularly low gold values, which again is almost certainly the explanation for that discrepancy we saw in the Huvishka coins earlier, that it's purely a function that either myself or Pankaj happened to measure a group that contained either an unusually wide or an unusually tight distribution, and that's the reason for the difference. A lot of the time, you don't actually need tests of statistical significance. It's useful to understand the concept. It's useful to understand what it means. It is useful on occasion to present that data. And I think the article Pankaj does is a very good case of where using those tests is useful, because it sort of tests your own assumptions about what's going on. I had a lecturer in biology at university who liked to introduce all talks on statistical measures by saying, if you cannot plot it on a graph in a way that is immediately obvious, no statistical test, no matter how sophisticated, is going to make it real. His point was that you should always be able to clearly see in the data that something is true. You shouldn't have to use a statistical test to prove it. And that if you were doing that, there was a very real danger that you were engaging in some kind of special pleading to see something you wanted to see. So in this particular case, what I've done is, this is the Samudra data we were already looking at, but the 2 gray bars at the top are Pankaj's data for 2 of the phases of Huvishka. And these are relatively wide within the Kushan series. These are quite widely distributed sets of coins. On the Kushan charts, they were very large bars, but you'll notice that the Gupta coins have a much greater, much wider distribution of values than their Kushan equivalents. This is something I suspected a decade or 2 ago looking at data, but I didn't really have good data to kind of see it as clearly as this now. And it appears that Kushan coinage is generally much tighter in the gold values that it has. And there are exceptions, and that's why I pointed up the fact that the Tiger Slayer and the Archer have very small samples. Now, we're not quite comparing like with like. These are individual phases of production in the Kushan, whereas they are types that may have been issued across the whole reign in the Gupta. But even if we compared the whole reign of Huvishka at both mints, it would still be tighter than most of these Gupta issues. And that, I think, has the potential to tell us something very interesting about Gupta coinage. I think one of the things it tells us is it just wasn't quite as important for a Gupta mint to get its gold content precisely to the same target value as it was for a Kushan mint. What precisely that means, I'm not sure, but I would suggest that a plausible hypothesis is that the Gupta gold coinage was more widely accepted as for monetary value, and that its face value probably exceeded its gold content by a greater amount than did the Kushan. We know that at the very beginning, the Kushan coinage is largely presentational. It doesn't really circulate. The Kushan coinage is also much, much smaller than the Gupta coinage. So I think what you're seeing is the effect of gold coinage having adopted a much more widespread and well-accepted economic role. Once it's done that, you don't have to keep the gold standard with quite the same precision that the Kushans do. Having said which, and Pankaj makes this point in the article, what we desperately need is to be able to break these Gupta coins down in the same way we can break down the Kushan coins into individual mints and phases of production to then see how much things vary within an individual phase or at an individual mint in the same way we were just able to see the Kushans. That is, I think, just inherently interesting data we are now getting from these much more comprehensive XRF studies that Pankaj and Sanjeev have been doing. This is just to reiterate the point. In statistical methodology, it is widely assumed, this is how it's used in the social sciences, in biology, that you will go out and do an experiment and you will test your data at the end to make sure that you're ruling out the null hypothesis. And so you're dealing with essentially one data point, and the statistical test is saying, yeah, 95% chance this isn't random. In historical methodology, we tend to search for outliers, and we're working with data that's largely the product of deliberate decisions. We are much more likely to be fooled if we depend solely on the statistical tests for significance. In history, it's like we have a bag of sweets that we've allowed people to eat, right? And we come to the bag of sweets when it's nearly empty, and we discover that everything we pull out is chocolate oranges, right? It's not a reasonable inference to then assume that the bag of sweets only contained chocolate oranges at the beginning. So we have to be aware of the distortions which are not random that occur in our samples. These show the same data for coins for Chandra. People who aren't familiar with Gupta coinage may not be aware of this. There is a lengthy argument in the literature about whether coins in the name of Chandra should be attributed to Chandragupta II or Chandragupta I. Myself, I believe Pankaj, though I don't want to put words in his mouth, believe that all of the coinage was issued by Chandragupta II after the reign of Samudra. Sanjeev Kumar has made an argument that a section of the coinage should be reattributed before Samudra, and that and he has, in the process of doing that, used some of this data in order to support that claim. And I realized as I was preparing the talk, it would get far too complicated and massively blow out the time, right, for me to go into the full details of that very lengthy debate over what's issued by whom and exactly what the data might or might not tell us. What I want to do here is simply point out that the throne reverse of the Lion Slayer is also a very small sample. It has the same feature as the Tiger Slayer and Archer types. There is a possibility that there's two possibilities. One, that they're very small samples and it's just a product of them being very small samples. The other is that they're very small samples because they were coinages that were issued in a relatively short period, that they're very coherent as coinages, and that their distribution is a function of that, and that's why they look different to everything else, and that the other coinages might look more like them if we could break them up into component parts, which we can't do at the moment. And because we can't do it at the moment, when I first started looking at this in sort of January, February, And I think Pankaj asked me about doing the talk a few months after that, and I was still thinking about it. I thought that it might be possible to use this data to look at the question of the exact sequencing of these coins. The broad conclusion I came to is that this data isn't fine enough to solve that kind of problem. It's not granular enough. It needs to come down to that granularity we have for Kushan coins, which would almost certainly mean that we would need more tests, because I suspect there aren't enough actual coins tested to drop down to that granularity. You'd have the same problem we have with Kushans, that as you drop down to the granularity of individual phases, we don't have enough results for some phases to say what's going on. You'd have the same problem here. But I think hopefully the talk has shown that there is a great deal of potential in this kind of numerical data, and that the difficulties of interpreting it are worth working through because of that potential. I think we know a great deal more about how Kushan mints managed their gold content today than we did 30 or 40 years ago. I think we can now see that there is a real difference between the way Gupta mints managed their gold content, their gold coinage, and the way Kushan mints do it. There is no question that the Guptas inherited an already existing system for managing gold content and just continued it. It is quite distinct in a way that suggests somebody is inventing their own system from scratch, and that their knowledge of the Kushan gold is essentially superficial. It's based on having examples of the coins, not a continuity of personnel and workmanship, which is a point worth making, because we know that in the Kushan Shah case, in some cases, there are continuities of workmen between the Kushans and the Kushan Shahs. So I think it illustrates, I've got across some of the difficulties, but I've also hopefully got across some of the potential. As I think we move into the next decade or so, XRF machines are less and less like scientific research instruments and more like a set of scales. They're something that can potentially be available simply to record any and all coins that we deal with. But thank you very much for listening.